everybody, welcome back. Time for our second video in this chapters series of videos. You know, the joy never ends, right? So in this particular video, we're starting chapter 17.2. This is the part that has to do with curved mirrors. And I actually broke this chapter section down into three parts. So this is part A, there's part B and part C. That way I can kind of keep them a little bit shorter. And each one of them kind of focuses on a little bit of a different section. So this particular video is just sort of an overview, introduction to some of the key vocabulary having to do with curved mirrors and the images that are formed by curved mirrors. And then part B, or video B here, will have to do with drawing ray diagrams. So it'll introduce drawing ray diagrams for concave mirrors. And then the last one, the third video, part C, will have to do with drawing ray diagrams for virtual images. And so that has to do with convex and concave mirrors as well. So again, it's three different sections, trying to keep it short for you so they can kind of watch it a little bit at a time. So trying to break it up a little bit. Also want to mention that the ray diagrams that we're going to be doing in these videos, we're going to be covering these really extensively and going through these a lot during the meet number 2 this week, whatever day we end up doing that, usually Tuesdays, right? So anyway, come to that meet. It'll help you draw it. I'll record it. I may have to do an extra little one to help you draw those. But again, we're focusing on technical drawing skills today or over the course of this particular chapter. So make sure you've got your pencil, you've got some paper, and that you've got a straight edge ruler available to you. This one, you don't need the protractor nearly as much. So that's kind of a good thing. If you've got a good straight edge nearby, then you're set to go for this. So anyway, this one is all about curved mirrors. I don't know if you can, I should probably kind of close that so you can kind of see this thing. Curved mirrors. This big thing's called the Bean, by the way. It's a sculpture over there in the city of Chicago, kind of near where I grew up. It's a really cool sculpture. And it was one of the things that's really interesting about it is that it is entirely a mirrored surface, but all of the curvatures of the mirrors are all different. So you get this really cool funhouse effect. So you've got a spot underneath it where you can walk it, where it's like an arch mirror over your head. And then you've got this big blobular shape around the outside. Super fun in terms of kind of looking at yourself and seeing what your image looks like. So with this, I want to introduce the two main categories of mirrors that go along with this. And these are the terms concave and convex. You can see them on the screen right there. Concave mirrors and convex mirrors. It has to do with the reflected surface and what the shape of that reflected surface is. So these are always going to be curved mirrors. When we draw them, we're always going to draw them way more curved than they actually are. But this will give you sort of an idea. So if you take a look underneath here, underneath the center of the bean, see how this looks like a cave? Well, that would be called this surface up. Oops, sorry, I did that wrong. This surface up underneath here would be called a concave mirror. That particular, let's see if I can get a color there. Something like that. A mirror that's shaped like this, where this side is the curved side and you're looking up this direction. That's what we call a concave mirror. So again, typically we draw them this way with some sort of an object, out, here, someplace like that. There you go. So that is a concave mirror. Convex mirrors are the other side. So like this outside edge, like if you're standing over here, there's a dude over here and there's some people that are on these surfaces. So if you're the other way around, where you're standing and the curvature of the mirror is the opposite direction, we call those convex mirrors and shaped that way. So again, if that outside is the reflective surface and you're sitting on that side, that's convex. So concave, again, the easiest way to think about it is think about being inside the mirror cave, and that's how you can tell which shape that is. And they have different ways that they make you look. So like the funhouse mirror that's down there is alternating different wavy sections that are partially concave and partially convex. We're going to be dealing spherical chicken with perfectly concave or perfectly convex. There's all kinds of in between, kind of half Ripley, gross looking mirrors that do all kinds of fun stuff. So with this, I just want to remind you that concave and convex mirrors are kind of around all over the place. There's lots of different examples other than fun houses that are being done. So for example, if you've got like safety mirrors, like the passenger side mirror on a car, which says objects in the mirror are closer than they appear, is actually slightly convex. If you're talking about this thing up in the center here is a solar oven, you can boil water in that thing, that's concave. If you've got these sorts of mirrors, these sort of frog eye mirrors where you can see around corners, there's one of these by the fire station on Lake Tahoe Boulevard, if you want to look that over by Tahoe Mountain. But anyway, that allows you to see around corners. Those are convex as well. This one upside down, we'll talk about that later, whether that's concave or convex. It's hard to tell from looking at that screen. Same thing with this one, where you get these weird little distorted images to it. And then you've got the magnifying sorts of images like this, where you're talking about a concave mirror. Again, slightly curved images, so you can kind of see something and magnify it to make it bigger, or you can make it, increase your field of view. This curvature can be used for a variety of different purposes, depending on what you want to do. So just some examples of some curved mirrors in your everyday life. So with this, I'm going to move this kind of towards the middle. We've got some vocab as we're starting to kind of think about, well, how do we draw and represent these sorts of mirrors? And again, this has to do with ray diagrams, but there's some basic vocabulary about the shape of a curved mirror that we need to get some of this language out in place. So you can kind of see the language over there on the right, principal axis, center of curvature, etc. But these are some key terminology that we need to be able to use. I want to mention this as well because this kind of becomes helpful for us as we get going. The concept of a concave mirror being a converging mirror and a convex being a diverging mirror. These two things sort of will maybe help you understand how the rays work in a ray diagram. So a converging and a diverging mirror. You'll see an example of what I mean by this in just a second. So let's assume that we have our mirror right here. And I want to point this out. When we draw curved mirrors, we're always drawing them super curved, like, oh my gosh, like way curved. In the real world, compared to the actual rays of light themselves, they're relatively straight. They're only slightly curved. So this is a massive over-exaggeration. And we'll have to take care of that when we're doing some ray diagrams. Even these are massive over-exaggerations for the actual shape of the mirror relative to the size of the rays that are bouncing off of it. So in any case, we're going to talk about this curved mirror. This is a convex mirror, concave mirror. Sorry, I'm looking at the different words. Concave mirror. We have a couple of different things that we can use to sort of denote how curved it is or how straight it is. And that'll give us some information about what kinds of images it's going to form, how much magnification or distorting effect it'll have, that sort of thing. So first thing is that we have this line down the middle called the principal axis, which is the center of this. I want you to think of a concave mirror as being one slice of a giant spherical mirror, if you can imagine an entire range. And that principal axis is literally a radius. It goes from, through the center of the mirror all the way to the center of what that sphere of curvature would be. So kind of keep that in mind. Principal axis. A lot of times as we're drawing this, it'll help us orient where what the curvature of the mirror is relative to the item. A lot of times we'll draw items sort of like standing on the principal axis. It just makes it easier for us to use. So principal axis, again, is a radius through that center of curvature of that particular object. These other things that are going on here in terms of what we got going on here, we have these things called the focus and the center of curvature. So in terms of what these are important geometric points in terms of kind of how this mirror works. So the principal axis always goes through the center of the curvature because this is the center of the sphere. That's what the center of curvature is. We could draw infinite numbers of radii, that would go out towards this. And if this is a perfectly spherical mirror, then we would have literally a center of curvature this way, one this way, one this way. And those could all be different principal axes. We're only going to draw one. Just the horizontal one is the one that we will draw. Center of curvature is literally that. This is the middle of the circle. The focal point of a concave spherical lens is halfway between the center of curvature and the edge of the mirror itself, the reflective surface. So if this is the radius, right, the radius of the sphere, the center of curvature is equal to the radius, right? We would just call that 2f. Why do we call that 2f? Because what we really care about with mirrors is where the focal point is. And that's a really important geometric point. So if you take a look up at this image up here, this converging mirror image right here, why we call it the focal point is because if we have very distant parallel rays coming in and hitting a mirror, they will all pass through the focal point, not through the center of curvature. So again, that's the definition right there of the focal point of a mirror. That's what we would call F. So we've got the principal axis now is kind of like our horizontal axis. It's one of our radii. The focal point is the distance where all of those kind of parallel light rays will converge. And then the center of curvature is the center of the sphere. So those are different things that we can use to plot. The last thing I want to mention is focal point versus focal length. This spot right here is called the focal point. The distance between the focal point and the mirror is the focal length. That's all it is. A lot of times the focal point is abbreviated with a capital F and the focal length is abbreviated with a lowercase f. For the purposes of what we're doing right now in a crazy environment, they're pretty much equivalent ideas. The focal point is a place in space. The focal length is how far away is that space from the surface of the mirror. So there you go, some kind of a key geometry of concave mirrors. So now how do we use these to draw some images? So I don't know if you're aware of this or not, but you can actually start a fire with a basic spherical concave lens. Please do not go start a fire in Lake Tahoe right now. Do not tell them that I am your physics teacher or that you learned this from me. But it is indeed possible to do this because a concave mirror will focus parallel rays onto the focal point. So if you think about what's happening here, is that this mirror is taking all of those light rays from the sun, which are incredibly intense and hot, and taking all those rays and focusing them on one spot. And if you actually have a little curved mirror at home, if you got a makeup mirror, you can use this. But if you hold a piece of paper out in front of it, you'll see that there's a circle of light. When you get to the right spot, that circle of light gets really, really hot and really, really bright. That's how you experimentally determine where the focal point of your mirror is. And that tells you something about the curvature of that mirror, because if you know what the focal point is or the focal length is, then you know the center of curvature. It can give you an idea of the size of that. So ray diagrams for drawing this. Again, we're going to be practicing these in meet number 2, how to draw some of these ray diagrams. So let's take a look at what we've got. We've got our concave mirror right here. We've got our object, and our object is something that's out at infinity, like say the sun, something way out, and that's what we're saying, just really, really far away from the mirror itself. So light rays are going to come in to this mirror essentially parallel to the principal axis. See, the principal axis is the center line right in the middle. That's just gonna like our horizon in our drawings. But right here is the principal axis. I usually call it PA as opposed to P, but that's our central axis. We've got our 2 major kind of geometric points, C and F, center of curvature, and the focal point or the focal distance on there. So these rays, when they come in parallel to the principal axis, they will bounce off through the focal point. Notice how they've actually drawn angle of incidence, angle of reflection, that the normal line extends through the center of curvature. Basically, the normal line perpendicular to the lens at that particular spot is going to go right through the center of curvature. So we always know where that particular spot is. It's a way to draw it. But again, parallel rays will bounce back through F. And those parallel rays are coming from all different spots on this item. So we've got 3 that are actually drawn here. There's an incoming ray here, bouncing back this way. There's an incoming ray here, bouncing back through F. And then there's actually one that's drawn along the parallel axis, the principal axis, that's coming in and bouncing straight back through F. And if I drew another one that was coming in basically, this spot, I would draw it straight to the mirror, and that would bounce it back through F. And if I had a ruler, those would actually be nice, neat angles and not look like curvy. But again, all of these different rays are going to bounce back through that spot, effectively concentrating all of those rays on the focal point. So that's how we start to draw ray diagrams. We draw them parallel to the principal axis and then bouncing back through F. It's a really important set of things. So if you've got a ruler, again, make sure that your ruler, if you're trying to draw one of these, literally is parallel to the principal axis, which you'll start off with. Make sure that these 2 lines are parallel. And then when you draw your reflected ray, that they bounce back through the point that's noted as F, the focal point of that mirror. So just a couple of things to kind of keep in mind as we're talking about sort of what these images are and the images that are formed by these sorts of mirrors. So a couple of things to know. Images, when you form them from mirrors, when you form them from this sort of thing, it's very different to say, hey, we've got a hot spot that's forming out here on this. There's something real that's going on. This is not a virtual image. In plane mirrors, right, the image just exists in the mirror itself. Even if you shine a flashlight at a mirror, you're not going to be able to start a fire with that mirror, with the plane mirror. But with a curved mirror, you're forming an actual real image. This is basically a miniature sun that you're forming an image of on that piece of paper. We would call that a real image. Again, it doesn't exist in the image, in the mirror. You can project it on a screen. So over here in the top right, you can actually see that someone is doing this. They're holding a little curved mirror right here. And then on this piece of paper, this is the window, the classroom window. You can kind of see there's stuff hanging in the window. There's the horizon outside that you can actually collect that image and project it onto a screen. That's a real image. Similarly, right behind my picture, I'm going to move me over to the side. Here is another real image where you've got a candle. That candle is emitting light rays that are bouncing off of this curved mirror, and they're actually projecting the image of the candle all the way over to the screen upside down. And you can see that that image of that candle right there is inverted. By the way, this one's probably inverted as well. Not all images are real. Some of them are virtual. Like these images in here are virtual images, right? Those are images that exist in the mirror themselves. But when you're bouncing it off and collecting it on a screen, we would call that a real image. Same thing right here, by the way, we've got another virtual image that's in here. This is a dental mirror. So I want to mention this other thing. So real versus virtual, important terms. And then magnification is our other term. You guys know that mirrors are capable of making images either larger or smaller. That's why we use makeup mirrors and things like that. So you can tell from this one right here, the image is quite a bit smaller than the window itself would be, right? It's on a piece of paper. The window itself is huge. as opposed to this one that's behind my head. This image of this candle right here looks to be quite a bit larger than the candle itself. So you can magnify or you can reduce objects. If you take a look at the dude in this one, he's reduced. He actually, his image looks smaller than the original dude does, versus this one when he's a lot closer, it's quite a bit bigger than the original dude was, or these teeth over here are bigger, they're magnified. So again, two other vocab words as we're dealing with curved mirrors that become important for us: real versus virtual images. Real images are projected onto a screen from real rays, as opposed to virtual images, like in plane mirrors, are sort of behind the mirror or exist in the mirror, cannot be projected onto a screen. And then magnification versus reduction. Does something get larger or smaller? So there you go, some introduction to curved mirrors, some different key vocabulary, and thinking about starting to draw some of these ray diagrams. So there you go. And I will see you with the next one, where we're going to go into much more detail about drawing ray diagrams. Get your rulers. See you there.